Electricity Committee webinar. My name is
I gotta go this thing.
I am the Managing Director for Electricity and Energy Security at NASEO. Welcome. Well, before we get started, just a few housekeeping items. This is a meeting, so you're not automatically muted when you're coming in. So if you're not speaking, please mute yourself. But hopefully if you have a question, you can either raise your hand and we can unmute you. We have a few options for Q&A. And we also have opportunity to have questions in the chat. So if you have any questions, feel free to put them in the chat at any time, and we will get to them as we're going through the webinar. As I should have mentioned from the outset, this webinar is on innovative technologies to support a resilient transmission system. We had a very successful similar panel discussion during NASEO's meeting in February, but lots has happened in the transmission space since February, and so we're very excited to have three excellent speakers today to enlighten us a little bit on what is happening and how they're seeing the space evolving. Again, if you have any questions, please put them in the chat or unmute. We're hoping to make this as interactive as possible. So with that, we'll start out with Dr. Adria Brooks from the Electricity Delivery Division of the Office of Electricity at the U.S. Department of Energy. She graduated in August of 2020 from the University of Wisconsin-Madison with a PhD in electrical engineering and a certificate in energy analysis and policy, and joined DOE first at EERE and now at the Office of Electricity. And we're excited to have Adria give us a quick update on the transmission needs study as they're unfolding and the different studies that are unfolding at DOE. So Adria, take it away.
Thanks. You can go to the next slide. So I'm just going to give a super high-level overview of a lot of things we have going on within our office at DOE. I'm sure folks have heard all the different webinars and things that have been coming out recently. So just a high level here, and then I'll dive in to just one thing that we're working on. So in January, the department released a Building a Better Grid initiative to the Office of Electricity. This is going to move over, we're in the process of moving over now to the Grid Deployment Office, which is a new office stood up by the department only a few months ago. So we have lots of engagement and collaboration efforts going on, right? I'm here today. We have folks from our office who are kind of flying all over the place this summer to meet with people. We have lots of transmission planning activities. The one I'll talk about today is the transmission needs study, but we also have the National Transmission Planning Study and the offshore wind study as well. There's a lot of new financing tools. So $20 billion that was granted to us through the IIJA. Sounds like there's more coming our way, which is exciting. So we've got information about a lot of these to get money out the door for transmission activities. We have several permitting activities that we've always had at the DOE. Those aren't necessarily new. And then of course, DOE's bread and butter, the transmission related research and development, which we've done for a long time. You can go on to the next one. So just to name, oh great, no, this is perfect. So the transmission needs study, just to give an overview of this. So this study is a triennial review that we put out, and it's meant to review both current and now anticipated future needs of the grid. So when I say needs, we're talking about a few different things. So reliability and resilience concerns, congestion, of course, we've always been putting, or for the last 20 years, we've been putting out these congestion studies, transfer capacity limits between regions, as well as trying to connect new generation to the grid. You can go on to the next one. Great. So the analysis that's included in this study, so it's going to look a little bit different from previous studies we've put out. We will continue to review historic transmission and generation installations, so looking at the last 10 years of data there. We're also taking a look at wholesale electricity prices and seeing what do trends in prices tell us about where there's congestion on the power grid. We review over 40 different industry, academic, and national laboratory reports as part of this to try to understand what does industry say where there's issues on the grid that need to be addressed or where transmission could address those needs. And then to get at this anticipated future needs question, we are looking at the results of several recent published capacity expansion models to see what they say about where new transmission would be needed under different future scenarios in 2030 to 2040. And there's a lot of different ways the department intends to use this study. For example, helping us to prioritize where we send funding out the door, right? But among other things, it does enable us to designate national interest electric transmission corridors, or NITCs. We're in the process now of putting out a consultation draft. So in the next few weeks, we hope to have that published and out the door. And then once that's out, we're opening up a 30-day comment period for states, Indian tribes, and the regional entities. So the FERC planning regions, the NERC assessment regions, to provide us with feedback. We'll incorporate the feedback and then send it out for public release, targeting later in the fall. We'll see how the timeline shifts. But that's our current plan for the study. And then there's a comments email here at the bottom. So if you have questions about this besides what I can just answer now, feel free to email us and we will get back to you on that. So that's all I had just in terms of an overview of the study. Again, pretty high level. So I imagine there's a lot more questions than I was able to provide answers for. I'm happy to take a few questions now to the extent that we have time, Kristen.
Great. Yes, Adria, thank you so much. While we wait for people to have questions, please feel free to put questions in the chat or raise your hands. One question that I've heard from states too is NASEO members are also very involved in the National Transmission Planning Study. And so there was a question of what kind of the difference between the planning study and the needs study are.
Great. Yeah, so the needs study is really an assessment of what are the issues that we're seeing now based on the reports that are already out there. The planning study is DOE's effort to say, okay, if we were to take planning from a regional level and do it at a national level, what are the transmission solutions that we would see that would help us address different power feature scenarios that the community comes up with? So at a very simplistic level, the needs study is an assessment of the current state of the grid, and the transmission planning study is more of a look at what would be the grid that we would want of the future.
That sounds great. And then there was one question in the chat if you're interested in kind of industry reports as part of this, and so should those be sent also to this email address, or how would you like to receive those?
Thanks. So we did, we hired some consultants to do like a pretty broad search of industry reports. Once it's out, you should take a look and see what industry reports are already included in the draft. And if there's something missing that you think should be in there, then we have this 30-day comment period to where you could submit those to that email address to let us know that you think it should be included.
Great. And then maybe one final question. You mentioned that the consultation draft will be released in about 30 days, the end of August, to the states, Indian tribes, and regional grid entities. Are there any specific questions or things that you would like the states in particular to review?
That's a great question. In a general sense, do the needs that you know exist on the grid, are they captured here? Or are there things that are new that are surprising and you question those results? So those two things, right? Just really wanting to test the validity of this and being sure that we haven't missed anything. You all on the ground probably know things that we maybe have missed, so it would be good to hear that.
Great. Thank you so much. I don't see any more questions. I just want to say thank you so much, Adria, for coming in and giving us a quick update on what's going on at the DOE side. We always appreciate that, and we always appreciate from the state side, the NASEO members in particular, to provide comments. So thank you for that opportunity. And I should say that we're planning with your office to host another webinar just specifically on the transmission needs study in September. So NASEO members, stay tuned for information in the week ahead or a newsletter on that.
Great, thanks, Kristen.
Thank you so much. And with that, we will turn it over now
Oh, you're muted, Kirsten.
Thank you. I muted myself. So we will now turn it over to David Townley. He will talk specifically about how to accelerate grid modernization and decarbonization with modern advanced conductors. David Townley works with CTC Global Corporation as Director of Public Policy, where he communicates with federal and state policymakers about the benefits of using high-performance transmission conductors to increase electric grid efficiency, capacity, and resilience. He has a Bachelor of Nuclear Engineering, a Bachelor of Arts, and an MBA Studies at Georgia State University. So David, thank you for joining us, and we look forward to your presentation.
All right, get myself unmuted and that'll go better. Thanks, Kirsten, for the introduction, and appreciate the opportunity to address this this group today. Certainly, I want to comment on what we want to cover, and that's reconductoring on the existing systems, including new builds, rebuilds, talk a little bit about wildfire risk mitigation and grid resilience and some grid flexibility. We'll talk about a couple other grid enhancing transmission technologies. They're also used for rapid grid increases as well as grid flexibility. Next slide, please. So what is an advanced conductor? And I've got a picture there of a legacy conductor. That ACSR is still the most widely used conductor in America and in the world. It's about 100 years old now. Steel wire is the support structure, and aluminum wires wrapped around it are what carry the current. In the advanced conductors, and I'm showing ACCC, but that's just one example of 4 that are available in the US today. The steel core is replaced by composite core. That's lighter, stronger, and you can see that a shaped aluminum is used, and that fills up those holes you see in the ACSR. There's about 28% voids there when you use round wire, and so we just fill up the voids. That gives you 28% more aluminum in the same diameter, and that aluminum is annealed, so it's a lower resistance. That now gives you, for the same diameter, the same size conductor, you can get 2 times the flow down that same conductor as you could for the legacy conductor, and still not hit your sag limits. And because there's more metal there as well, it's much more efficient. There's about 30% lower losses on the advanced conductor. And that carbon core center, unlike the steel, as it heats up, the steel expands, and if it's attached to the towers, it's going to sag. Tower has to be designed high enough to accommodate that sag. But the composite core advanced conductors have a much less sag, about 50% less sag than the traditional. And that means that you can use smaller towers, fewer towers during construction, but it also means wildfire risk mitigation, and that's being recognized across the board, even in some of the IIJA spending pieces, programs as well. Next slide, please. So if you do Reconductor, what do you get? What does it do? And the picture here is of a existing tower in the Netherlands. They have a very large offshore programs going on in Netherlands and in Germany. Once you get that energy to shore, though, you've got to distribute it. And that's where congestion points all through the grid have to be addressed. And they're addressing them by reconductoring on the existing structures with advanced conductor. That lets them get up to 100% more power down the same line, depending on which kind of conductor you use and how the utility wants to rate those lines, operating versus flexible capacity. Get 30% lower line losses, plus or minus, depending on which advanced conductor you're using and how it's being used, how heavily loaded. You're not rebuilding the tower. So it's half the cost, roughly half the cost of the conventional rebuild strategy. And because you're not rebuilding, you don't need to do construction permitting and environmental permitting. You literally are using the same practices to change the line out that you would for maintenance or for storm recovery. So it's very fast. You can get that done in 18 months or so from the time you've decided to the time that you can energize the line. And because it is that low sag conductor, you do get the wildfire risk mitigation as well as other low sag benefits. Next slide, please. I'm going to use one example from a March study with Grid Strategies. They were looking at advanced conductors in the existing transmission corridors and how that might accelerate low-cost decarbonization. One of the areas that they looked at were old lines today that are getting replaced just wire for wire, but it's the same thing, it's in-kind replacement. They said, look, how much old wire do we have? And they said that they found there's more than 200,000 miles of transmission lines that are over 60 years old during the next decade. And so they, in order to just get a feel for how big is this opportunity, they said, what if just 2.5% of those lines were reconductored per year, 25% over a decade? What kind of impact would that have? And they were surprised by the result. It created just reconductoring on the existing structures for these old lines created about 27 gigawatts a year, or over the decade, 270,000 megawatts of renewable generation that could be connected to the grid just as a result of this in-kind upgrade. And they moved around about 3.5 billion megawatt hours of renewable energy around the grid. They reduced CO2 emissions by 2.4 billion metric tons. That is 40 very large 800 megawatt coal plants running base load for 10 years. That's how much CO2 emissions were reduced in the NERC region. And they estimated that with the lower cost electricity as well as the lower cost reconductoring, saved consumers on the order of at least $140 billion over that decade. Next slide. So reconductoring is the fastest, lowest cost way to add substantial capacity to the existing grid. This happens to be American Electric Power reconductoring in the Rio Grande Valley. Next slide, please. So just a comment on new line construction or even rebuilding. Here you're going to have to build towers. You're going to have to, in new line, you got to buy right of way, land, and so on. And you're going to use a different conductor. So an advanced conductor instead of a legacy ACSR conductor. And that's going to add one
from someone that said, I'll return to the office on Monday.
That's going to add about 1 to 10% more on your project cost. But the savings alone are enormous for the consumer. And so they very rapidly pay back that additional investment. And just what I show first up, the 30% lower line losses. So having more metal on there, having a lower resistance, getting that energy savings, that alone in most projects that I've seen would give a payback of about 1 to 3 years to pay back that increased project cost. But then you've provided the consumer with an additional 20, 30, 40, 50 years of additional energy savings. And because it was more efficient, not as much generation is required to serve the same loads. You're delivering more of what you got. And of course, the carbon emissions were lower, less fuel got burned. You could deliver 2 times more capacity, both operating capacity as well as this flexible capacity to give you a more resilient grid, flexible grid going forward. And you get the low cost, the low sag, greater ground clearance. You can see in the little cartoons there on the right. Certainly wildfire risk mitigation. You're just up higher on the structures. Greater resilience to the grid, and commented earlier, you could use lower towers, shorter towers, or fewer towers if you wanted to take advantage of construction cost reductions for the low sag conductor. But we would comment that all the new lines should be using modern conductors, modern advanced conductors to create a modern grid. Next slide, please. So in summary, for advanced conductors, grid efficiency matters. It should be part of the design process. Reconductoring is the fastest way to add substantial capacity to modernize and decarbonize the grid. Even building new lines with advanced conductors. That's a win for the consumer, for the environment, and for the grid. And low sag advanced conductors help with wildfire risk mitigation and adding more resilience to the grid. Next slide, please. So I was asked to comment a little bit on some other grid enhancing technologies. Grid enhancing technologies is sort of a subset of what DOE calls advanced transmission technologies, but they're focused on the existing grid, getting more technologies that can get more out of the existing grid, more capacity and flexibility, more energy efficiency, faster solutions, lower cost solutions than rebuilding or building new lines. And so they've kind of showed them in 2 different areas, a sensor and software category of technologies and a hardware category of technologies. So in the sensor software technologies, see things like dynamic line ratings, topology optimization. Okay, topology is just, that's the layout, right? So while dynamic line rating is looking at the line itself. What are the ambient conditions? What's the wind speed? How much is it sagging now? What's the temperature? And how much more capacity can go across there before I get in trouble? I get ground clearance issues. That's dynamic line rating, kind of done in real time. Day ahead, lets you get some estimate of how much more can I squeeze out of that grid tomorrow or in the next hour. Topology optimization, that layout, this is more a software solution. It looks at the whole grid and says, okay, I want to turn off this switch so the power is going to flow this other way, or I'm going to turn on this switch so that the power will redistribute by turning on and off. And these are pretty much on or off, switching in the system to be able to change the flows around the system, optimizing, lowering costs, lowering losses, improving system performance. Generally, these are shorter term, real-time type planning opportunities, not particularly used for long-term planning. So they're going to be improvements in the control room or in various kinds of analysis tools, metering, even AI-assisted operator decision-making. On the hardware technologies, and I've named a couple here, power flow controllers and advanced conductors. We talked about advanced conductors. Power flow controllers, sort of like topology optimization, but topology optimization turns on and turns off a switch. It's either on or off. Power flow controller on the grid, installed on the wires themselves, actually change the resistance to the flow of electricity. In AC terms, it's called impedance, but it's going to change, it's going to make it more resistive, and so power will want to flow a different way, a lower resistance way. And so instead of all on or all off, you can have more nuance, a little more control over how that power is going to flow on your grid. And these are technologies that cost a bit more, more capital intensive, and also move more into the realm of longer term reliability and resilience planning. There's a couple in the FERC transmission planning, NOPR, that just came out. They did call out 2 grid enhancing technologies that they're asking the planning processes to kind of pay particular focus on during the planning process. And that was dynamic line rating and advanced power flow controllers. And the advanced power flow controller, certainly some of the software controls are a little better nuanced than older versions, but they've made it easier to actually put it up, install it, and take it down and move it somewhere else. So a little easier to move those controllers around the system in a way that maximizes the benefit on the system itself. Next slide. So we wanted to cover advanced conductors, reconductoring, new line construction, wildfire risk mitigation, grid flexibility, and we wanted to introduce a couple other grid enhancing technologies for rapid grid capacity increases and flexible capacity. And I just wanted to observe on that these technologies are tools in a toolbox, and you choose the right one for the right opportunity, but they also can be used not only individually, they can be used in tandem. You can certainly use load flow controllers on advanced conductors, for example, very easily done to maximize the reliability and the resilience of the entire electric power system. So with that, I want to move to the last slide and look forward to questions a little bit later.
Great, thank you.
Back to you, Kirsten.
Thank you so much, David. And I have one quick follow-up question before we go to Christina. And just a reminder to everybody attending, please feel free to put questions in the chat or raise your hands. But, you know, this was really interesting and a great presentation, and I appreciate it. I'm wondering if you could maybe put a little bit into context to what the state energy offices in particular are focused on. You know, a lot of our members work on state energy security plans, on the implementation of some of the IIJA funding. So where do you see those kind of new technologies fit in?
Good question. The NASEO members have not usually been looking on this side of the meter, as we know, right? And we've talked about it with a number of the members over the years. And now all of a sudden they're thrust onto this transmission distribution side, and it's like, what's going on? you're about to go out and certainly within the rural communities, within munis, within co-ops, smaller utilities, that's particularly a lot of the money that you're getting that's going to go out in solicitations are going to be for these people. And they too, they don't have all the facts usually, and they follow the leader more so. They try to share as they can, and certainly they've got an association that helps them understand as well. But you're going to see some of these technologies come back in, and so I think in the solicitation, part of this was just to give you a heads up of how some of these technologies that you may see coming back at you in the solicitations, how to use them, how they may be presented to you in terms of grid resiliency, wildfire mitigation, instead of moving wires, replacing them with advanced conductors, low sag conductors, or even using other grid enhancing technologies that'll come back and say, we want to use this technology to solve this problem. So you've got your hands full. It's going to be challenging, wonderful, but hopefully some of this discussion helps introduce some of the ideas that you're likely to see coming back at you through the solicitations. And you're going to be engaging. You're going to be engaging in transmission distribution processes that have not been your forte in the past. And now they're going to be thrust upon you, and you will do great. But it'll be great insights, good learning process, a challenging learning process, but in some ways bringing new ideas to the table. I mean, you've seen the other side of the meter and the influences that happen over there because of what happens on this side of the meter. So I think that fresh insight is going to be wonderful. Don't hesitate to speak up. There's this grinding process that's happened on the other side year in and year out for transmission planning and planning and planning. But this fresh ideas, fresh look, fresh questions, I think will be very, very vital to the process going forward.
Great, thank you. Yes, and that's exactly why we're having some of these webinars, to provide that insight and that input and discuss these ideas. So appreciate it. So we'll go to Q&A. I see a question in the chat box, but we'll go to Q&A at the end because I want to give Christina time and opportunity to talk. So Christina Hayes is the new Executive Director of Americans for a Clean Energy Grid, and she previously served as Vice President for Federal Regulatory Affairs at Berkshire Hathaway Energy, and has been an energy regulatory attorney for about 20 years, mostly Midwestern and Western utilities, helping to navigate the complex process of all these things we're talking about. Today, she's also served as an administrative law judge at the Public Utility Commission of Oregon. So Christina, looking forward to hearing your presentation.
Thanks so much, Kirsten. So far we've had the rocket scientist in Mr. Townley speaking, and I'm the attorney, so I'm here to start fights. So hopefully we can have an engaging conversation. If you want to go to the next slide. I want to talk more about kind of the regulatory atmosphere around new technologies and kind of from a utility perspective. I'm still taking that hat off from just about a month ago. And I've certainly heard a lot of utilities engaging with how to adopt some of these new technologies. So from an incentives perspective, in terms of utilities being motivated to add some of these new technologies onto their transmission systems, it really started with EPAC 2005, which provided for financial incentives for the Federal Energy Regulatory Commission to provide return on equity adders or QIP or abandoned plant or other sort of incentives, financial incentives, to move transmission in a certain way, to take chances, plan riskier plan lines that might be riskier to build. So regional lines, that sort of thing. And so FERC issued a rulemaking in 2006 with a small adder, about a 50-point adder, I think, on alternative technologies, but ROE adders have been less in favor since 2012. The commission wanted to make sure that it wasn't just a way for utilities to kind of lard up their return onto customers for things that would have been built otherwise. Additionally, technologies that maybe were not quite so novel were still being proposed as innovative. That was also frustrating. And so I think a lot of the progressive commissioners over the last 10, 15 years have really expressed a lot of frustration with not being able to really crack the nut of how to incentivize, how to use some of the technologies that Mr. Townley just brought up and to make sure that they're deployed in the most effective way. So in 2020, FERC took another crack at transmission incentives that would really kind of boost returns, especially as interest rates had declined over time, ROEs had been declining over time, and so there was more pressure on transmission incentives to kind of balance things out at FERC. There was, kind of some timing and some tension around the changeover administration last year. So FERC kind of put the brakes on the transmission incentives rule and said, first, why don't we figure out what it is we want to incentivize? Instead of, giving everybody great big ROE adders for belonging to an RTO or for, adopting certain technologies, why don't we figure out exactly what we're doing and then return to incentives? But in the meantime, we've heard from a couple of FERC commissioners that they really have concerns about incentives more broadly, because it is designed to add to rate base or revenues for companies at the expense of customers. And so for those who take the view that it's just the straight up used and useful that should be subject to, a traditional DCF rate of return, return on equity calculation and all of that, maybe these incentives don't have as much of a place as originally considered. I'll also note there's some dockets we'll talk about in the next slide, but there've been some proposals out there. Like, are there ways, because these technologies, as Mr. Townley discussed, are less expensive to put on the system and maybe are they're more bang for the buck, they don't always have as great of a return for the utilities, right? And so there's some proposals out there around sharing the benefits for these new technologies. Say if if there's a anything that costs more than $1 million for if it gets more than $10 million in benefits, then after and above that, the utilities get to share some of that. So there are some ideas around that, but that's just sort of out there. Next slide. Thanks. So FERC, especially in the last 2 years, has really been digging in deeper into some of these transmission technologies, really focusing initially on ambient adjusted line ratings and dynamic line ratings. So I think of this as ambient adjusted line ratings as sort of the long term. I confess it's August, so I'm at the beach. It's sort of the bigger, longer waves, and dynamic line ratings, it's more of the the sharper peaks. So FERC built up a record and issued a final rule just this past December that would require RTOs and ISOs that are scheduling transmission, within the next 10 days to apply AARs to those transmission schedules, right? So that should show, so instead of just applying a static rating, it allows the transmission operators to look a bit closer at the conditions to see, is it going to be cooler out? Can we get some more capacity, squeeze more capacity out of the existing transmission? So it's a time period of not greater than an hour. So it's, that's kind of a long time in transmission speak, rather than the 15, shorter increments. There are some parts of the country where AARs don't work. They don't have the conditions that allow for it to work. Again, I used to work for a company with utilities throughout the country, and there were some utilities that said AARs work great for us, and others said no, they don't. But DLRs are fantastic. So different conditions work better in different parts of the country. Compliance filings were just due a couple of weeks ago, and implementation must begin in 3 years. So this is something that there's some concern out there about. I know utilities have expressed concern that this is going to be very expensive to implement and the cost will exceed the benefits. Other concerns that I've heard from utilities, just kind of generally over the years, if new technologies are being adopted on existing facilities, there are utilities that express concern that if others are putting new technology on their facilities, that creates a liability problem for them. If your local load serving utility has load serving obligations, has reliability obligations through NERC, they express the concern that others being on their system might jeopardize their compliance, that if new technologies are required, instead of building out the system, that could lead to underbuild on the system and could jeopardize their ability again to meet NERC reliability standards. Again, I'm not taking a position on these. I am raising all the concerns, so you know these arguments when you hear them. I see Mr. Townley giving me scrunchy faces. So I'll let you argue with me later. I know you have great rejoinders on these. Another issue to think about is as these new technologies are being put on the system, as you know, we have we have 3 interconnections, but it is one grid across the country, right? The grid does not stop at state borders. And so there can be the concern that if new technologies are placed on certain lines, but not the next set of lines, that it simply is a matter of, kind of pushing the congestion around the system, making sure that that it relieves congestion points, and doesn't create problems in other locations on the grid. Mr. Townley was great in bringing up that long-term planning. There are a lot of concerns about whether or not these new technologies should be considered in long-term planning. And then also the financial incentives as just raised for the utilities. So to the extent it's more expensive than traditional builds and a utility has to go in and justify it in their rate proceeding, then they have to make the case as to why these new technologies are worth the extra rate recovery. I just want to throw out all the arguments, fair and balanced, right? So anyway, I want to point out that FERC considered ambient adjusted line ratings and adopted that final rule, but they were concerned they didn't have a complete enough record on dynamic line ratings. Again, dynamic line ratings work. They work in isolated. They work kind of more isolated incidents. It's a place where you can add sensors and monitoring systems, communications, analytics on existing lines. It doesn't work everywhere. So, for instance, I worked with PacifiCorp, and so they implemented dynamic line ratings in a couple of places in Wyoming. So, where the wind would blow, the line cooled down. It was great. They got more capacity on the line at a time when the wind farms were generating more wind. And it was great that they were able to implement it there. When we went in to talk to FERC, they were like, great. So how can you do this everywhere? Well, not everywhere is Wyoming. And also there are a number of folks who are concerned with, still kind of working through whether and in what instances to adopt ambient adjusted line ratings on their system in the next 3 years. Pivoting now to dynamic line ratings in such a short period of time, they're concerned about their ability to do that effectively. So FERC is thinking about it slowly. Hopefully, more consistency though with the commission and the staffing and the commissioners on the commission. Hopefully, there'll be some stability for some time. Next slide. Okay, so kind of next, what comes next? So this is what FERC is considering right now. So grid enhancing technologies, as Mr. Townley discussed, were raised in the transmission planning NOPR that's currently pending at FERC. This has been long awaited, much sought after. This is the follow-up to Order 1000 that was issued about a decade ago. Only dynamic line ratings and advanced power flow control devices were proposed to be used in regional transmission planning processes. The ANOPR, which was issued last year in this proceeding, was really much broader. So the NOPR really kind of narrowed down to what they were able to get a majority on, what they were able to get really kind of 3-4 votes on. And so it gives pretty good insight as to what the commission found acceptable. So, and what's more likely to be considered in a final rule, as opposed to their other issuances that the commission will be coming out with that they've said that, not everyone's always as enthusiastic about. So I think there's a pretty good chance that we're going to see these in a final rule, maybe by the end of the year, early next year. And then the other piece that I know some folks have asked about is IIJA funds. Dr. Brooks raised the Smart Grid Investment Grant Program. That's $3 billion. It's a matching fund, which was updated. Initially, it was in the, what was it, the ARA about 10 years ago, 15 years ago, with the Recovery Act. So it's an update to that program and provides significant additional funding for it. And that's to provide more flexibility for extreme weather events on the grid. Also that $5 billion in competitive financial assistance. So that means you have to submit a proposal and DOE has to choose you. That's what makes it a competition, right? So, and that's for states, local governments, and tribes to to work with utilities or other transmission developers with innovative approaches to hardening and enhancing resilience of the system. So I know folks are trying to shine up their projects and garner support for those to compete for that $5 billion. I think we're going to see probably RFPs come out in the fall for those. Also, DOE is kind of looking at all of their all of what they were given in the IIJA, and honestly, what they might be getting in the Inflation Reduction Act that has been proposed. That's been proposed that I know Senate's considering right now, and what will be passed in that. So there may be more additional opportunities in that. And so DOE is looking at all of this holistically in terms of having a grid deployment office and really kind of trying to make the most of the funding that's available and trying to make it go as far as possible. Okay, next slide. So I guess I think for my old PUC hat and my old FERC hat, which I hope is somewhat familiar with folks in the state energy offices in terms of, so how can we make the most of all of this? And again, I also think with the utility perspective, so, utilities have, first of all, there's a tremendous need and a tremendous incentive and really a kind of a favorable climate right now to focus on developing transmission. So as they propose various facilities, it's a great time because that's when they need a CPCN. That's when they need rate recovery. And so it's a great time to go to them and say, okay, so how are you, making the most of these various opportunities? And if not, I think somebody put in the chat, why not? That's when they need some help. In some instances, new technologies works, and sometimes new facilities entirely are needed. So it's not one or the other. It's really kind of an all of the above situation where we are right now. As noted, some technologies work better in some places than others. It doesn't always, not everything works great everywhere. Wyoming is very windy. And dynamic line ratings work great there. Ambient adjusted line ratings, not as much. So it might be a good time to, work either with DOE or with WAC or with others to start to think about what technologies work best in the best places. And also, I kind of want to throw this out there, kind of looking ahead. Mr. Townley and his colleagues are great about keeping me honest and saying, don't only focus on grid enhancing technologies, because that does not always include advanced conductors, right? So I think new technologies or transmission technologies is kind of a great umbrella term that covers GETs and advanced conductors and whatever comes next, right? We're not done. I had a conversation with a friend from another walk of life who's looking into quantum computing and, kind of what, this new, digital technology can do, but, it's only the digital sensors that are eligible for DOE grants. And there's this whole computing piece that's not, but, it's a great way to optimize the system. So they're still trying to figure out how to, figure out energy applications for something that's traditionally thought of as, more in the data space. So I guess I want to say, we're never done, right? There's always new technology, and let's make sure that if rulemakings are instituted or, tariffs or something like that, let's make sure we use as broad a terminology as possible to include the thing that comes next. And the last thought I want to leave you with, I leave you with this picture of these 6 little boys. I joke I could have gotten through the pandemic, but I'm not sure I could have gotten through the pandemic and my kids going through puberty at the same time. And so they started off, they were shoulder height to me, and now I am shoulder height to them on a good day. And I think about planning for the grid. We have to plan for what the grid's going to be like in the future. I have to buy clothes for the size my kids are gonna be, not the size they used to be, right? And so for all the things that we're planning for greater electrification, for EV cars, for, everybody plugs in their phone, all the things that we need to electrify and plug in. We really need to, use new technologies to plan for the future, because it's not just enough to replace what we had before. Thanks.
Great, Christina. Thank you so much for this great overview. And I'm keeping an eye on the chat. Anybody has a question, please feel free to add it. But before we go there, I just wanted to ask one question. You touched on it a little bit, but maybe could illuminate a little bit more. You having had that utility experience, what are some good ways for especially the state energy offices to maybe engage with the utilities on some of these issues early on? It's different than, the PUCs and the regulatory environment. But as the states are thinking about some of these opportunities you outlined in the IIJA, potentially new law coming down, how could they engage with the utilities on these issues?
So there are some terrific financial incentives, right? And so a utility is going to be thoughtful about the costs they're incurring when they go to the rate recovery proceeding, right? Or the CPCN, right? They know they have to, when they're planning this big package of facilities, transmission, et cetera, they are very concerned about their stakeholders. And so being an ally and saying this is the cost of being an ally, right? We can help you get this funding. We can help you get approval and rate recovery. If you can show us, how these technologies work, how they can be implemented, how they can reduce costs for customers in the long run. And frankly, it helps utilities keep rates down, which then gives them headroom for further investments in renewable resources, in additional facilities down the road. So it actually gives the utilities additional flexibility, especially if they get that extra boost from the state energy offices.
Great, thank you. And I see one question in the chat, maybe specifically to you, David. The question is, so are most new transmission lines being built with these advanced conductors? And if they're not, then why?
Very good question. They are not generally being built with advanced conductors. And the largest single reason is CapEx. I showed in my slide, I led with a project will be more expensive because it's a more expensive wire. It's got more metal and other benefits, right? But when you're doing least cost planning, and that is focused only on CapEx, then you wind up being more expensive because the benefits are not being considered. FERC in the NOPR that's out for the first time listed 12 benefits and said, you ought to be considering these benefits. And we'll see how that sorts out. But one of them, and I just focused on one of them, just the energy savings alone, the loss reduction of having a more efficient, lower resistance conductor, that's the big payer. There may be 11 other benefits that come into play, but that's the biggest one in the process today that is just not routinely even considered. And as a result, and we said this to FERC, their rate is not just and reasonable if, in making a decision on a conductor in a project, and the lowest cost is chosen instead of the best benefit, then they have caused the consumer to bear the energy cost of 20, 30, 40 years of higher energy costs because they didn't consider upfront making an investment in efficiency. And that's when it needed to be made. And that's our comments. But certainly the FERC NOPR opened that up. And just a quick anecdote on what often happens, even if a utility said, I can add just a little more, I can add a little bigger wire or advanced conductor, something else that gives that benefit, and I can calculate the savings and the consumer gets the savings. That's the right choice to make. I'm going to make it. And they make that choice and go in for recovery. And our recovery process is a adversarial process. And so the first thing they get slapped on the head is, you didn't need that big of a conductor. You didn't need that capacity. And this is the difference, that more conductor meant more capacity, when we're saying more conductor also means more efficiency. And if it's lower efficiency that pays that off, that's the right investment to make. But today they're charged with gold plating. You were gold plating that solution, and their return is at risk. And it's just, they're not willing to do it. I can go do the same old thing I've done for the last 50 years. Nobody complains that much about it. I get my return. It's just not worth the risk. And so we see that just as an anecdote, that gold plating is a big enough risk to say, until it becomes part of the process, that evaluating those benefits makes for the best package, not the least capital cost, then we'll see a change.
That's where the utilities need allies among, state energy officers and others who can talk about those benefits, because if the utility does it, it's self-serving, right? And so David makes a great point in terms of, you overbuild the system up front, but, I don't know of any examples of stranded costs in transmission, right? It all gets used eventually. It may take a while. And so the DOE has other programs that can help with that part of the financing, but that's a risk that it's very difficult to ask the utility to bear in the short run when it has that kind of long-term public good.
Yeah, that's a really interesting conversation on this question of benefits. And I'm wondering if you've seen any, you talked a little bit about the federal effort to bring in some of those benefits and the cost benefit equation, but have you seen any good examples maybe on the state side where that has been really successful, where the PUC or the State Energy Office has provided some of those, or has considered some of those benefits?
I'll bring to bear what happened just within the last month. And there are a couple of other good examples, but let me just mention this one. In Vermont, for the first time, the utility proposed, look, we're going to, instead of just doing this in-kind replacement, we're going to upgrade it and we're going to make it more efficient. It's going to cost a little more, but it'll be more efficient, and it's going to give us more resilience going forward. What do you think, Commission? And the Commission's response nominally was, well, of course. And you shouldn't only be doing it in that project, it should be done all the time. So, it's like, okay, it's about, the word is getting around that it is the states as well that need to make the opportunity. Most of the utilities would be quite happy to spend a little bit more money and make a little bit more money. That's how they make their return. But if it's good for the consumer, and the commissions can say, okay, make sure the benefits are considered, show me the benefits, show me it's good for the consumer, it's good for the environment, it's good for the grid, now make that investment. But that has to come from the Public Service Commission, really. And some of them are beginning to take that action.
Great. One question that I want to make sure we're getting that was asked in the chat, are there any challenges considering these new technologies such as advanced conductors to integrate those into the existing grid, connecting them with the older elements or segments of the grid? So I'm not an engineer, so I'll pose this question to you all.
I would make a couple comments that let's just use the example I gave of 50, 60-year-old structures. Some utilities will say, those are long past their depreciation date, and I'd like to invest and get something I can earn on. That's true. There may be conditions, though, where it's just, you actually just have to replace it. It's just so old, you can't put anything on it. It's about to fall down anyway. Well, there are some cases of that. But an example on the flip side is in the Northeast just a month ago, they reconductored a 98-year-old series of structures, right? So-called H-frame, wooden H-frames. But for them, the return was so fast for them to reconductor that even if they had to rebuild it in 10 years, it was more than paid for and benefit to the consumer. So for them, it's like, okay, it can still hold up. It's held up 98 years. Will it hold up 10 more? We think it will. And away they went. And so those are the kinds of trades, even in the AEP example that you saw, the trucks that were up there and so on. These were over close to the coast, and they were going to tear them down and rebuild them. That's the classic approach. But they couldn't. They couldn't get an outage long enough because the reserve margins were so low and it was so tight in Texas. And so they decided to use the existing structures, just put up advanced conductor on the existing structure. They had to repair some, but they didn't have to tear them all down. They had to inspect them. They had to make some repairs, but that's what they do in maintenance all the time. So yes, there can be conditions where it just won't work, but there's also a lot of conditions where I'd really like to reinvest in it because that's how I make my money, but maybe we're making enough investment across the whole board now that that's the right thing to do. I can get another 10, 15, 20 years. Yeah, I can do that. And that's what we're seeing quite a bit, is that reassessment of, yeah, it's an old structure, but maybe I can still use it, squeeze out some more in this lower cost way to get the capacity I need now.
So I think reconductoring requires, in some instances, strengthening of the towers, but other technologies require sensors on existing lines, like dynamic line ratings, and they don't require a full rebuild. So it really depends on the kind of technology that we're talking about.
That's exactly right. Yep.
Great,
They're all, and I tried to make the point earlier too, they are truly tools in a toolbox, and the utility just needs to be able to understand when to use a hammer, when to use a screwdriver.
That sounds like a plan. Are there any other questions in the chat? I don't see anything in the chat. I don't see any hand raised. I know we're nearing the top of the hour, so I'm just going to say a huge thank you to Adria, David, and Christina for coming on to this webinar and tell us more about the landscape of transmission and innovative technologies in the transmission space. We will continue to work on this issue from the NASEO side for sure. As the states are contemplating state energy security plans, program narratives for 4101D, and other